So per usual, we want to make sure that we're taking strong, effective, efficient, organized, cohesive notes. I like all my adjectives today. So that starts with writing down the title of the lesson as well as today's date and the fact that it is Unit 7, Day 4. So we're talking about sex-linked traits. And today's date is Wednesday. I'm sorry, it's not. It's Thursday, October 29th. That's incorrect. Give me 1 second. Just delete that. Today is Thursday, October 29th. The objective for today's lesson is that biologists will be able to predict offspring ratios of sex-linked traits by completing additional practice problems. And the essential question that we seek to answer, why are males more likely to show sex-linked traits? Why are males more likely to show sex-linked traits?
Are we supposed to answer?
No. That's what we will hope to answer by the end of the lesson.
Oh, okay.
Okay, that should be time. So in review, we've talked about these types of inheritance so far. On Tuesday, we introduced complete dominance, in which you either have the trait or you don't. That's because in complete dominance, your dominant allele will always mask the recessive allele. And what we want to think of as we think about these different types of inheritance is what happens with the heterozygous genotype. What trait does the heterozygous genotype express? In complete dominance, the heterozygous genotype expresses the dominant trait. In incomplete dominance, which is the second type that we introduced yesterday, the heterozygous genotype expresses a blend of both phenotypes. And in codominance, which we also introduced yesterday, the heterozygous genotype shows both traits equally. So you end up with spots or you end up with stripes. You might end up with a coat or a mane of different colors, multiple colors. We also have different ways of annotating these types of inheritance. With complete dominance, we use a capital letter and a lowercase letter. With incomplete dominance, we use capital letters, but we also use apostrophes, and we call that apostrophe prime. And with codominance, we use capital letters, but you use two different letters to represent the different alleles. So I might have a B for black and a W for white. So we've got to keep these different types of inheritance in mind. Okay. Any questions about this?
No.
Thank you. Moving on. So when it comes to multiple alleles, there are 3 or more possible alleles for an individual trait. Yes.
I ain't gonna cap. It's like it's raining outside, so all my stuff just turned off.
Okay. Yeah, I know we're experiencing some tough weather right now. So I got you. If you go in and out, that's okay.
All right.
All right. So today we're introducing another type of inheritance which falls on multiple alleles. So that means that there are 3 or more possible alleles for an individual trait. Blood type is an example of this. We've got 3 possible alleles for blood type. We've got A, B, and O. And the other types of inheritance we've discussed so far, there were only 2 possible alleles. We only had the dominant allele and the recessive allele. Now we're talking about some traits that have multiple, at least 3 alleles. Of course, each individual still only gets 2. You won't see a person with 3 alleles, but there are at least 3 options for the 2 that they get. Everybody only has 2 because you only get a copy from your mother and a copy from your father. So you should be, I know we're not doing a great job of highlighting the words right now, but I do still want you all to write these slides down. Where is everybody today?
Some of them probably don't have internet.
I didn't even think about that. Okay. So human blood types have 3 alleles, A, B, and O. A and B are considered codominant alleles, while the O allele is considered recessive. So if we look at this image down here at the bottom, it's kind of a goofy looking cartoon, but it's pretty helpful in terms of seeing what the outcome of these multiple alleles could be. We've got 4 different blood types. You could have blood type A, blood type B, blood type AB, or blood type O. Blood types A and B can be both homozygous and heterozygous. You can have both A alleles makes you blood type A. But if you have one A allele and one O allele, you're technically heterozygous, but you're still blood type A because O is recessive. And sometimes you'll see this lowercase I representing the O allele. Same thing with B. You could be homozygous with B, meaning you have 2 B alleles, or you could be heterozygous and have 1 B allele and 1 O allele. Again, because B is dominant to O, that person would still be, even though they're heterozygous, they're still blood type B. Blood type AB means that you have one A allele and one B allele, and blood type O means you're homozygous recessive. So you just have two O alleles. So definitely write down this table. This is basically what I just said. Now, keep in mind, there are two ways to write the genotype. We can just do the A's, the B's, and the O's, but sometimes you'll see I with a superscript of A or B or O. Or I'm sorry, you'll see I with a superscript of A or B, and then the recessive allele is just a lowercase I.
Don't they like have stuff like be positive or be negative?
Yes. Um, that is not so. That's not the exact same thing as the. So these are the only three alleles for blood type, but then there are other. There's another measurement of your specific blood chemistry that makes it positive or negative. I'll just go back for a quick second. You can see that here: O positive, O negative, B positive, B negative. The positive and negative is telling you what additional antibodies are present in your blood. So that's a good question. Okay, so here's some additional at the bottom. I'm sorry, it's kind of being covered up now, but some additional hints about the alleles. Again, we can use I to the superscript A to indicate the A allele, or we can use the lowercase I to indicate the O allele. Does anyone need more time here to copy this down? Okay. So more practice problems. Stacy has blood type A, which we can indicate with that genotype, I superscript A, lowercase I. And her husband has blood type B. He's homozygous. So I superscript B, I superscript B, or IB prime, IB prime. Blood type AB is known as the universal recipient, meaning that people who have blood type AB can receive blood from everybody else. So they wish to have a child with type AB. Is it possible? So what's the first step we always follow when we are making Punnett squares or solving Punnett squares?
The key.
Yes, thank you. We need to make our key first. Then what should I do? What should I do after I've made my key?
Make the box.
Good. Yeah, I need to actually make my Punnett square. So let's do it over here. I like to draw these days. Okay. And what do I put on the outside of the Punnett square?
The genotypes.
Yes, the genotypes of who? Whose genotypes?
The parents.
The parents. Good. Yeah. So in this case, again, it doesn't matter if the mother goes on top and the father goes on the left, or if the father goes on top and the mother goes on the left. That doesn't matter. That's just a matter of preference. But in this case, we are presented with information about Stacy, the mother, first. We are told that she has a blood type A with a heterozygous genotype. She's got IA prime and a lowercase I. So that means that she has the genotype AO. AO. That's why the lowercase I is there. So she's AO. We're also told that the father, Stacy's husband, has a blood type B and he's homozygous B. So he just has two B's. So I know you guys remember this at this point. It's probably really easy for you, my very intelligent honors students. Okay. So what goes in box one? What genotype goes in box one?
BA.
Okay. And I'm going to write AB just because that's kind of, how we typically would hear it, A blood type AB, but BA works as well. You can write it in whatever order you like. What about box two?
OB.
And this time I'm going to do it the other way. I'm going to write BO. That's typically how you would see it. What about box three?
AB.
Good. And then box four?
BO.
Good. All right. So what phenotype, what's the blood type from box one? Well, actually, hold on. Give me 1 second. Let's do it like this. We've got three blood types. A, B. I'm sorry, we've got four blood types. A, B, and O. So what percentage of our offspring have blood type A?
Zero.
0%. Good. None of them are blood type A. What about blood type B?
0.
2.
We have two offspring that are blood type B because
Oh, my bad.
you're good because B dominates. O. B is the dominant allele. So it dominates the recessive allele O. So that means that I've got 50% of my offspring with blood type B. What about AB?
2.
I also have two offspring with AB blood type. So that's another 50%. And then what about blood type O?
0.
0%. Good. Okay, so I don't have any offspring with blood type O. So the question, if we go back, asks, is it possible that they have a child with blood type AB? Well, it most certainly is. In fact, they have a 50% chance of having an offspring with blood type AB. Okay, another one. A baby with blood type AB is born to a mother with type A blood. A man, James, claims to be the father. James has type O blood. Could James be the father? Okay, let's check it out. So, per usual, first thing we need to do is make our key. So in this case, we have only 3 blood types that are represented here. We've got a baby with blood type AB. We've got so blood type AB, which is B, genotype AB. We've got a mother with type A blood. So what are the potential genotypes for type A blood? There are 2 of them. What could they be? Hopefully you wrote down that chart. What 2 genotypes could give me type A blood?
A, and AO.
Yes, I could have AA or AO. And then we're told that James, who's a man who claims to be the child's father, has blood type O. What genotype gives us blood type O?
OO.
OO. Good. So we know that the baby has the blood type AB. We know that James has the blood type OO. And we know that the mother is A. So now we make our Punnett square. We just need to make a Punnett square and cross James and the mother. See what the outcome is. So, in fact, we're going to end up needing to make 2 Punnett squares because there are 2 potential genotypes for the mother. What should I do with the first Punnett square? Walk me through it. What should I do in my first Punnett square here?
A, B.
What's that?
Um, add A to one of the sides. AA to one of the
Okay,
sides.
so let's put them. We can put the mother on one side, but there are two potential blood types for the mother. So which one do we want to start with?
AA.
Okay, let's do AA here, and then we'll just put James on the top. He's OO. So in this case, I get nothing. I get all AO. So the only blood type that's possible if the mother is AA and mates with James, the only possible, sorry, the only possible blood type for the baby is A, but we know the baby is AB. So if the mother is AA, then James is definitely not the father. But let's see if she's AO, can it work? Let's see. So we still have James at the top here. And we've got the mother on the side. In this case, I can only end up with a type A or a type O baby. So what this tells us is that there's no way that James is the father because his type O blood could not have produced a type AB baby. James cannot be the father because there's just no way he could have produced an AB baby. Not possible. All right. So a little pop culture for you here. Maybe some of you are interested in celebrity relationships. But Future is claiming he is the father of Culture, who is Cardi B's daughter. Offset, who is supposedly the father of Culture, says no way. Cardi B is blood type AO, and Future is blood type B. Culture is type O. Is it possible that Future is the father? So again, we're going to have to make two Punnett squares yet again. Because we don't know what Future's genotype is. We know his blood type, we know his phenotype is B, but we don't know what his genotype is because there are two genotypes that could give you the blood type B. So blood type B can be BB or BO. So we've got to try both of those genotypes in order to determine if Future could potentially be the father. So Cardi B is blood type AO, so I'm going to put her blood type on top here. AO, AO. And Future is type B, so he could be BB or he could be BO. So over here, I end up with A, B, A, B, or I could end up with B, O, B, O. Culture is type O. So in this case, if Future's genotype is BB, then he can't be the father because we don't end up with a type O baby over there. Let's try the other one. I end up with A, B, A, O, B, O, or I end up with O, O. So between a AO mother and a BO father, all four blood types are possible. I could end up with AB blood type. I could end up with B blood type, A blood type, or I could end up with O blood type. All four are possible. So in this case, it's possible that Future is the father, although further genetic testing would be needed to know for sure. All right. And here's the further genetic testing that we would do. We talked about this in Unit 5. This is the DNA fingerprinting that we talked about. So if we've got Cardi B over here on the left, we've got Culture in the middle with both the purple and the red DNA segments. And then we have Offset as male 1 and Future as male 2. Who is the father based on these DNA fingerprints? Who would be the father if you're looking at this DNA fingerprinting?
I don't think we're on the same screen.
Oh, I'm sorry. So yeah, we talked about this DNA fingerprinting process in Unit 5. We've got Cardi B on the left with the mother. Those are fragments of DNA that have been gel electrophoresized. We've got Culture as the child in the middle with purple and red fragments from both of her parents. And then we've got Offset as male 1 and Future as male 2. So looking at this DNA fingerprint, who is more than likely the father?
Male 1.
Male 1, yes. And how can you tell?
Because it matches the babies.
Yes, you can see that there are more matches in the fragments of the DNA. We've got 2 matches here, 2 more right there, and 2 more right there. So male 1 has a total of 6 fragments in common with the baby, even maybe 7 if you consider this first one. And male 2 only has maybe 1 right there, but even that looks like it might be a little low. Maybe 2 right there, but that looks like it could be a little low too. So male 1 is certainly the father. Male 1 is Offset. Okay. So there is an exit ticket. I think there might be some errors in the exit ticket. So don't start with that. Start with the creating inheritance questions assignment. It's called the Honors Push for Standards Inheritance Practice. In this assignment, you're going to make 4 of your own problems based on the following guidelines. One of them has to be complete dominance and must show a 1:2 to 1 ratio. One of them must be incomplete dominance. The results can be anything. A third one must be co-dominance, and it must have a ratio of 2:2. And then lastly, you make a question about blood type. Additionally, if you didn't finish some work from yesterday, I know we've been kind of pushing it into the asynchronous time. If you still have some work that you need to finish from yesterday, I would encourage you to get that done as well. And I'm going to go ahead and fix the exit ticket so you guys can do that. I'll let you know when that's done. Okay, so it's not that the exit ticket has errors. It's just that we didn't cover the information that it asks about um, today. So you all will, I'll just remind you to do it tomorrow when we will have covered that information. So you'll just have 2 exit tickets to do tomorrow instead of 1. Okay, folks, it is now 11:35, so it's time for you all to enjoy your lunch period.